Hello and welcome to Algebra 2, Chapter 11.3, and today we're going to discuss geometric sequences in series. So they are slightly different than arithmetic sequences in series. So a geometric sequence is a sequence where the ratio of any term to the previous term is a constant. And so if I have this sequence, a term to the previous term, so ratio, so that would be 2, or 16 over 8, that would be 2. So really what's happening is you are multiplying by the same number every time to get to that next term. And that constant ratio is called the common ratio, just like we had a common difference. That was D before, it is now R. And our rule is A sub n equals A sub 1 times R to the n minus 1. So the first step is to decide, are these geometric sequences? And it has to work for every term. And so using our rule, negative 8 over 4, negative 2, 16 over negative 8, negative 2, negative 32 over 16, negative 2. So yes, that appears to be a geometric sequence. And so here we have 9 over 3, which is 3. And then we have negative 27 over 9, which is negative 3. No. Okay, not the same there. Next thing we want to do is we want to write a rule for the nth term of the sequence. Okay, so let's remember that A sub n equals A sub 1 R to the n minus 1. And our rule, we need to put in A sub 1 and we need to put in R. So R is what you're going to get by doing a term over the previous term. So R would be 2/5. And in fact, 0.8 is 4/5. So if I did 4/5 over 2, that would be the previous term. Just to show you how this still works. Okay, multiply by the reciprocal. We still get 2/5. And it would work the same way if you took a 0.32 over 0.8. So our rule then, A sub n equals A sub 1, which is 5, times R, 2/5 to the n minus 1, and you leave it exactly in that form because this is going to work for any n value. So specifically then, we want to find the 8th term. So A sub 8 equals 5 times 2/5 to the 8 minus 1, which is going to be 7. Remember, in your exponent rules, you're going to have to take 2/5 to the 7th power first and then multiply by 5, and you should get 0.008192. Okay, so the next thing it tells us is that we have one term that's A sub 3 equals negative 2, so the third term is negative 2. It's telling us the R value is 3 and it wants a rule. Well, let's write down our rule here real quick. A sub n equals A sub 1 R to the n minus 1. So to write this rule, you have to have an A sub 1 and you need to have an R. I have an R. I do not have an A sub 1, so we need to solve for our A sub 1. So if we use this as our nth term, so negative 2 equals A sub 1 R to the 3 minus 1, right, because that's my nth term is my third term. Negative 2 equals A sub 1 times 3 squared, which is going to be negative 2 equals A sub 1 times 9, or 9 A sub 1. Divide by 9. A sub 1 is negative 2/9. So my rule for my nth term then is negative 2/9 times 3 to the n minus 1. And you can write it like that, or you might like it better with parentheses. There's my rule. My 8th term then is negative 2/9 times 3 to the 8 minus 1, which is 7. So you're going to do 3 to the 7th. And take that times negative 2/9, and you should get negative 486. So next it's giving us two terms. We have the second term is -4, and we have the sixth term is negative 1024, and it wants us to find the rule. Okay, so just like we previously discussed, you write out my rule. To write a rule, I need my first value and my common ratio, of which I have neither, of course. But we're keeping in mind, if I have two unknowns, I must have two equations. I must have two equations to solve for those two unknowns. So we're going to write an equation for each term it gives us. So the second term, so a sub n is going to be -4, a sub 1 r to the 2 minus 1, and then we're going to have negative 1024 equals a sub 1 r to the 6 minus 1. Okay. The saving grace here is going to be that we have an exponent of 1. I forgot an equal sign. Let's try that one more time. Equals a sub 1 r. So you could solve for one of these. Tell you what, let's solve for r. So r is going to equal -4 over a sub 1, which means using substitution, this becomes... Nope, I didn't want to solve for r. I'm going to take you back and solve for a. A sub 1 equals -4 over r. Okay, I promise you that I think this will make it easier. -4 over r, because this is r to the 5th, which that's then going to become -4 r to the 4th, because that r cancels with one of those. That's why I solved for the a sub 1. Okay, divide each side by -4, and we're going to get 256 equals r to the 4th. How do you get rid of a to the 4th power? You take a 4th root. So r equals, the 4th root of 256 is just 4. So there's r. So let's come over here and do -4 over 4. So we get -1. So there is a sub 1. So my rule for a sub n equals a sub 1, -1, times 4 to the n minus 1. No, you cannot multiply that -1 times 4 together, because the 4 has to go to the power first. So do not simplify that. It does not simplify. So our last thing to talk about is going to be series, and we're going to add up these geometric sequences. And our rule now is the first term, a sub 1, times 1 minus r to the n over 1 minus r. So make sure we have that written down, and let's put it into use. So consider the geometric series 4, 2, 1, a half, etc. Find the sum of the first 10 terms. Well, let's write down our formula and see what we need to have. So S sub n equals a sub 1, I need the first term, 1 minus r to the nth, so I need the common ratio, and I need how many terms over 1 minus r, and so I need that common ratio again. So I should have everything. A sub 1 is 4. 1 minus, well, what's my ratio? It's going to be 2 over 4, which is a half. So we're going to do a half to the 10th power over 1 minus a half. Okay, and so if you want to work that out, you can, or if you just want to punch that in the calculator, you should get 1,023 over 128. So that's the sum of the first 10 terms. So the next thing I want to do is I want to solve for n, but notice where n is. N is an exponent. Okay, keep in mind we did a whole chapter on how do you solve for an exponent. Well, S sub n is going to be 31/4. A sub 1, still 4. 1 minus, r is still a half, but now this is n over 1 minus a half. So we need to whittle this down a little bit. So let's make this 31/4 equals 4 times 1 minus a half to the n over a half. And tell you what, let's multiply by 1/4 to get rid of the 4 and bring it way up top here. 31/16 equals 1 minus a half to the n over a half. So you're really then going to multiply by a half. You don't want to multiply by the reciprocal, you want to cancel that whole thing. 31/32 equals 1 minus a half to the n. Let's minus 1. So that's going to be negative 1/32 equals negative a half to the n. Multiply everything by negative 1. And we get a positive 1/32 equals a half to the n. And then the question becomes, how do I get rid of that half to get to the n? And you're going to go, oh yes, I'm going to remember my log properties of log base b of b to the x equals x. How do you get rid of a base? You take the log of both sides. So this needs to be log base a half of a half to the n. So log base a half of 132. So this all really kind of cancels. We have n equals log base a half of 1/32. Remembering that's not 1/32, it's 1 second. 1/2. Remembering your change of base, this is log of 1/32 over log of a half, and you just type that into your calculator exactly like that, and you get n equals 5. Okay, so because we're dealing with exponents, occasionally you're going to have to use those log properties. That's what I have for you today for 11.3. Let me know if you have any questions, and if not, I will see you in class next time. Have a great day.